Hi, I'm Nick Hoggard, and I'm going to talk about whether chaos theory controls evolution. For the purposes of this presentation, I will divide evolution into 4 stages. The physical evolution of the universe resulting in planets ready for life, biological evolution, cultural evolution, and information technology evolution. Now, all but the first of these stages have different ways of transferring information to the next generation. Biological evolution transfers information using DNA. Cultural evolution uses teaching to transmit information, and information technology transmits information on external media, that is external to the human body. So on a finite planet, you get food shortages, and when you get food shortages, you get starvation. And mathematically, this can be shown on the diagram at the bottom of the page, which is called a bifurcation diagram. If we assume that a species moves into a new ecosystem, we can see that the population curve starts at 0 and gradually increases, but there comes to a point where all the food is eaten up. And what happens then is what is called a bifurcation, which means that the population splits into 2 levels. And this represents the fact that there will be a high level followed by a low level, and this will alternate every 2 years. So the first year the species eats up the food, and the next year they find out they've eaten all the food last year and there's not enough to go around, and so there's starvation and the population goes down. And the year after that, the food supplies have grown again, and the population can recover. So it settles down into a 2-year cycle. If you get a bigger shortage, if you get a more lively population, more fit for the ecosystem, then you get a 4-year cycle, and then an 8-year cycle, and so on. And this is called a cascade of events. It's called a period-doubling cascade, or a boom and bust cascade. So this is a boom and bust cascade, and you can see that it starts off at 0 for when a population moves into an ecosystem. After a while, it eats up all the food, and then it bifurcates into 2 population levels which alternate, and then it splits into 4, and that takes less time than it took to get to the first starvation point, and in fact it continues to split into smaller and smaller pieces and at a faster and faster rate, and in fact there is an infinite number of bifurcations before the red line. And the characteristic of this kind of curve is that it happens very often in nature in different kinds of situations, and at the acceleration, that is the ratio of the intervals, gets shorter by a factor of 4.669, and this is called the Feigenbaum constant delta, and it is a universal constant, which means it applies to all kinds of boom and bust cascades. And this is just another example of the bifurcation pattern, just to show that it doesn't only apply to populations of animals. But this is an example of a dripping water tap, and the time between drips increases as the water flows, and as you turn the tap on, you get 1 drip at a time. Then as you increase the water flow, you get 2 drips together as they start to interfere with each other, and then you get 4 drips together, and so on. And finally you get turbulent flow. So you get these cascades in all kinds of situations, and they are in fact caused by finite resources. And finite resources can be modelled mathematically using something called the logistic map, which is shown below here. But it can also be used, you can also use something else. It doesn't have to be the logistic map, as long as it looks similar to the logistic map, it will always give exactly the same result. And this is the universal constant 4.669. So we think that all non-linear dynamic processes with finite resources have boom and bust cascades with 4.669 acceleration. Evolution is a non-linear dynamic process with finite resources. So the question is, can we find such a cascade in evolution? Well, to cut a long story short, if we look at cultural evolution, we see, if you look at the right-hand column, we see 7 new ways of evolving, which are called flexible behaviour, tool use, tool making, making tools with tools, composite tools, new inventions, and domestication of animals and plants. And in the middle column we see the different kinds of information transmission methods which were needed for each of these new methods of evolution. So we have parental approval and disapproval, tool transfer, which means giving a tool to the young, drawing attention, demonstration, communication of concepts, spoken words, and complete language. And if we look at the times and look at the ratios of the times, we find that they accelerate or they get shorter by the ratio 4.669. And if we go outside cultural evolution, we can, if we project the dates of these events in cultural evolution and try and estimate what dates will come after and what dates will come before, if we look first at the last 3 events, these are the dates which have been generated from extrapolating the dates from cultural evolution. We get 3,300 years before current era. That is the invention of writing. The next date is 1044, which is the invention of movable type printing, and in 1948 the computer. And we can also go backwards in time to the first date we get then is 1.1 billion years ago, and that is sexual reproduction, where you get DNA combined from 2 parents. And the date before that is single-celled organisms, where DNA is simply copied, comes from one source. And then the Big Bang, where you have no information transmission at all. So that in total is 12 ways to evolve, and all of those methods of evolution are still in use. And this is very difficult to see, but this is the timeline, and you'll be able to see this in the documentation afterwards. And it shows how the Feigenbaum cascade is drawn here on the green lines, and that is it's a logarithmic scale, which means that all events or all intervals will appear to be the same length, even though they're actually decreasing by a factor 4.669. I've multiplied them out again, so they will always all be the same length. So you can see how the actual dates which have been discovered by various methods, they all coincide with the Feigenbaum dates, except for the first two dates, Big Bang and the first life, and this is quite normal for for bifurcation curves, is that they start off slightly differently, but they converge to this acceleration of 4.669. So this is quite normal. So this is a absolutely classic convergence of events to the Feigenbaum constant. So that is the pattern. What is actually happening? Because we need some kind of explanation as to why we're getting this pattern. And the cascade pattern relates to the behavior of a single variable as the parameter is increased. So if we let the parameter be time and the variable be the population of the currently most complex species, so right at the beginning of the curve you see that it is 0 for a good while, and that the flat part of the curve there is before life evolved, so there's no population, the population is 0. Then you see when the first life appears, that is where the population line starts moving up, and it gets higher and higher as the complexity of the species increases, although it does slow down. And at this stage this is single-celled life, and all single-celled life adapts by mutation, and this always happens, I speculate, at the same speed. So what this means is no one species has a built-in advantage. They're all using the same method, and no species gets too far ahead. So you get a kind of you get an equilibrium where you don't get any boom and bust behavior. So then the first bifurcation there, where it splits into two, is the next stage of evolution, where you get sexual reproduction, which means that animals which reproduce sexually can adapt faster because they're using a better method, and that basically means that they always have an advantage over single-celled animals, and they will always experience, they will live in a situation of permanent boom and bust. And then from then on, every stage of evolution that happens, you get a doubling of the boom and bust pattern. So what future events are predicted by this theory? I don't know what the events are going to be, but the next event is scheduled for the year 2161, and the last event for the year 2196, and in between there should be an infinite number of events, but they will get infinitely small as they approach the end date. And whether this is the technological singularity or not, I think it's going to be a different event. I don't think it's going to be where machines evolve themselves and take over. So to summarize, it is finite resources which shape evolution into a 4.669 boom and bust cascade. Every bifurcation or complexity threshold in this cascade generates a new evolution process which is faster than the previous one, and it also generates a new method of information transmission, because the new evolution method can't be transmitted by the old process. And there have been 12 evolution processes in human history, and all of them are still active. And that's all I have time for, so thank you for listening.